Hi everyone, welcome back to another video in the Web Security Academy series. In today's video, we'll be covering lab number 7 in the DOM-based vulnerabilities module titled Clobbering DOM Attributes to Bypass HTML Filters. If you do not have an account on the Web Security Academy series, you can get one by visiting the URL portswigger.net/websecurity and clicking on the sign up button. I already have an account and I am logged in, so to access the exercise, I'm going to click on Academy. Select all content, all labs, and then do a search on DOM-based vulnerabilities and go to lab number 7 titled Clobbering DOM Attributes to Bypass HTML Filters. Alright, let's get started. This lab uses the HTML janitor library, which is vulnerable to DOM clobbering. To solve this lab, construct a vector that bypasses the filter and uses DOM clobbering to inject a vector that calls the print function. You may need to use the exploit server in order to make your vector auto-execute in the victim's browser. So the target goal over here is to exploit the DOM clobbering vulnerability in the HTML janitor library and then call the print function. Now we do have a note that says the intended solution to this lab will not work in Firefox. We recommend using Chrome to complete this lab. So as we've learned in the theory video, DOM clobbering vulnerabilities are browser specific. And so this specific vulnerability is only going to work on Chrome. So make sure you are using the Chrome browser and you're not using Firefox. All right, let's access the lab. Now notice over here, I am using the built-in browser in Burp. And so all my requests are already being passed in my Burp proxy. And since I am using the built-in browser, by default, I'm using Chrome. So if you're not using the built-in browser, you may want to make sure that you're using Chrome and you're not using any other browser. All right, so it looks like we've got a similar application as the previous lab. So it's a blogging application. You could click on View Post to view the content of each blog, and then you have the ability to leave a comment on each blog. Now, if this was a real-world pen test, whenever you see input vectors that get displayed back to you in the application, you absolutely have to test them for cross-site scripting vulnerabilities. So the input vectors over here that get displayed to me right away, I could see there's the comment field, the name field, and maybe the website field. So those definitely need to be tested for cross-site scripting. However, based on the lab description, I know that this is not vulnerable to XSS, and so we have to find a DOM clobbering vulnerability in order to perform an XSS attack. So the first thing that I'm going to do is right-click and click on View Paste Source over here and try to see what functionality is responsible for the comments section of this website. So let's try and make this bigger. Go down. And here we go. So you've got the comments section over here. It looks like it uses two scripts. The first one is HTML janitor.js. So this is a JavaScript library that uses a defined whitelist or allow list to limit the HTML content that you're allowed to add on the page to prevent XSS attacks. So this is what's preventing you from right away performing an XSS attack on these fields. We'll have to look at this JavaScript library in a bit. The next library that it's loading is /resources/js/load comments with HTML janitor.js. So this is definitely a custom library just based on the name of it. So we'll be reviewing that one first. But before we do that, it looks like it's using the load comments function in the load comments with HTML janitor JavaScript library, and it takes in as input the path/post/comment. So let's see what's in this path. So if we go over here, you could see we're already at /post. We're going to do /comment. Okay, so it's similar to the previous lab where you have all the comments that are added on this specific post ID, and we're working with post ID number 7. Okay, this looks good. Let's first view the custom script and then we'll go to HTML janitor. Let's open that. And I'm going to make this a little bit bigger. Now, when a user adds a comment, it calls the display comments function and it takes in the input of the user. And for the display comments function, it looks like it's just creating the web page that you see in front of you after you submit a comment. So you've got, let's see, a comments array. It creates a section element and then it adds an attribute to the section element that is equal to comment. And then it creates a paragraph element, and then it creates an image element. It adds the class attribute to the image element, and it sets it to avatar. And then from there, it chooses the source attribute for avatar. If it's already set, then it keeps the set value, but if it's not already set, it'll default to this value over here. So this was where the vulnerability existed in the previous lab. However, this is written correctly this time around, and so it's not vulnerable to DOM clobbering. Now, if we go down over here, it's doing that as well for the author field, and it's also doing that for the body field. You could see all of that in the web page. So if you right click on any of these comments over here and click on inspect, this is exactly what this script is doing. It's building this web page over here. So we saw the section element, we saw the P element, so the paragraph element, the image element, the source attribute, and so on. Now, the interesting part over here is that when it's adding the author of the comment, it's using the clean function in the HTML janitor library in order to ensure that this does not contain any malicious payloads that could lead to attacks like cross-site scripting. So again, this is what's preventing us from performing a cross-site scripting attack in the author field, but it's also what's preventing us from performing a cross-site scripting attack in the comment field as well. So let's look at that JavaScript library and see what this functionality does. So let's say .clean and look for it. Let's go down. And I'm going to try my best to read the comments because I do not want to read JavaScript, but we're going to have to read some JavaScript. So if we go over here, we've got parameters. So config.tags is a dictionary of allowed tags. And it looks like this is already set, so it's probably coming from here. Let's go over here. Let's say tags. And here we go. Okay, so it's taken from over here. Let's copy this. Put it in here. And if we go back over here, it tells you config.tags is a dictionary of allowed tags. Okay, so when a user adds a comment, you're only allowed this specific whitelist of tags. So you're allowed to add the input element, and inside the input element, you're allowed the name attribute, you're allowed a type attribute, and you're allowed a value attribute. You're not allowed any other attributes. In the form element, you're allowed the ID attribute, but you're not allowed any other attributes. And then you're allowed to use the I element, but you're not allowed to use any attributes with it. Same goes for the B element and then also the P element. So we're restricted to this specific configuration when we're adding a comment. Okay, interesting. So let's go back to HTML janitor. And then over here it says config.keep nested block elements, and that's defaulted to false. Okay, so we've got the clean functionality over here. It calls underscore sanitize. So where is that? And it's right over here. So just based on the naming convention, because I don't really code in JavaScript, but it looks like it's taking the parent node, and then from there, it just defining the DOM tree for that parent node. So everything that is under that parent node. And over here, you could see node is set to first child. Moves all the comments, and it continues to call .sanitize on the different nodes that are under that parent node, and then also it looks like the attributes of the parent node. Okay, so it looks like it checks if the tag element is allowed. If it is, then it sanitizes the first child node, and then it loops through the node's attributes. If they're not in the whitelist that we saw right over here, then they will be removed. Now, the DOM clobbering vector over here is with the dot attributes property. If we can clobber this value over here, so the value of dot attributes, then we could make attributes dot length undefined. And so it'll never pass through this functionality over here, which removes the attributes that are not already available in our configuration. And so if we're able to clobber this value over here, so the attributes value, then we essentially prevent the library from performing validation on our attributes. And the way we're going to do that is using a form element and an input element. So form element is allowed and input elements are allowed because those will get checked in the script before our value is actually clobbered. And so it's important that we use those. And then after that, once we clobber the attributes value over here, then we could add any attributes that we want. So the way this is going to look is as follows. So we're going to use technique number 3 that we learned about in the theory video. We're clobbering the attribute property using form parent child elements. So we'll say form ID is equal to anything. We'll just say X, but it can really be anything. And then we'll say input ID is equal to attributes. So this, once we enter it in here, so in the comment field, it should clobber the attributes property. Now, the lab requires us to call the print function. And so the way we're going to do that is we're going to say form ID is equal to X. And then we're going to say tab index is equal to 1 and on focus is equal to print. Now again, by using the input element as the first child of the form element, then it'll bypass the first check, and then the ID attributes will clobber the attributes property. And so it'll allow these properties over here that are not listed in the configuration of the HTML janitor library. And the way we're going to call the print function is we're going to use the onFocus event to call it when the input field gets focused, and we'll use the tab index attribute to specify the tabbing order of the element, with 1 being the first element. Now we do need a way to auto-execute the script, and so we'll be using the exploit server for that. But before we do that, let's copy this, put it in the comment field. Let's say test.test.ca, and then http test.ca and post comment. Go back to blog. Again, this is not auto-executing over here. We need a way to auto-execute it. And the way we're going to do that is by hosting a malicious script on our attacker-controlled server. And then we're going to send that script to the user. Now, when the user clicks on that script, it should auto-execute our payload over here, which we already added as a comment. All right, so in the body over here, we're going to use an iframe element. We'll say src is equal to the source of the post where we added our comment over here. So let's copy that, paste it in here, and then say onload is equal to, and I'll explain this in a bit, set timeout. This.src is equal to this.src plus, we'll call our form ID, which is X, and this just introduces a 500 millisecond delay. All right, I'm just going to make sure I wrote this correctly, and then I'll explain what we're doing. So post ID 7. Onload, set timeout. Okay, this looks good. I don't think there's any mistakes in it. So the idea over here is we need to introduce a delay using the set timeout function right over here to ensure that the comment containing the injection, which is available on post ID number 7, is loaded before the JavaScript is executed. If we execute this before the page gets loaded, which contains the malicious comment, then it'll just be calling an ID that really doesn't exist. And so we need to introduce a 500 millisecond delay to do that. Once that delay is completed, it calls the form payload, which clobbers the attributes element. So you could see over here, we gave it an ID of X, and so it's calling it by its ID. If you gave it an ID of anything else, you have to put that value right over here. Now this looks good. Let's store it and then deliver the exploit to the victim user. Now when the user clicks it, and here we go, it should clobber the attributes property, and then from there we're able to call the print function. Of course, we don't see it ourselves because the victim user is performing it, but if we go over here and then let's just call the print function, here we go. That's exactly what's happening in the victim user's browser, but we didn't see it because we sent the exploit to the victim user using our exploit server. All right, we successfully completed the exercise by exploiting the DOM clobbering vulnerability in the HTML janitor library and then calling the print function. Now, if you did find this exercise extremely difficult, that's okay. I wasn't able to solve it myself. I actually had to look at the solution to get a hint for what I needed to do. And so this is an expert lab, so don't worry if you weren't able to solve it on your own. It really comes by experience, and some of the labs are just really hard. All right, that's it for the DOM clobbering module.